Hey guys, in this video I will show you how to design primers for ARM-PCR in order to identify single mutation. ARM-PCR technology is used to detect single base mutations in For ARM-PCR, 4 primers are designed: forward outer primer, reverse outer primer, forward inner primer and reverse inner primer. The requirements of primers are: the size of primers should be 22 to 25 base pair and the melting temperature of primers should be 50 to 60 degrees centigrade. In this technique in ARM-PCR, basically 3 PCRs are run, in due to which 3 different type of products we will get. In first reaction, for the first reaction, we use forward outer and reverse outer primer. For second reaction, we use forward inner and reverse outer primer, and in third reaction we will use forward outer and reverse inner primer. So for this purpose we need to design 4 different primers to get 3 type of products. To design primers for ARM-PCR, I will use Primer Blast software, with the help of which I will design primers. So for example, I have a gene and the gene size is 6323 base pairs and consists of 3 exons. This gene code for hepcidin protein, and the protein is consist of 84 amino acid, and the gene is present on chromosome number 19. In this gene, there is missense mutation in which the glycine is converted into aspartic acid at position number 71 of amino acid. This mutation is present in exon number 3 and the coding region site is 212. For example, the nucleotide position in which the glue into alanine is 212 position. So now I will use Primer Blast software to design primers for this region. So this is my sequence of HAMP gene, and I have downloaded this sequence from NCBI. I have downloaded this sequence from NCBI by using this accession number. So we can download the sequence of any gene by using accession numbers. I have highlighted the exons of my gene with blue color, while the primers I am going to design will be highlighted with yellow color. As the mutation is present at position number 12 of coding region in exon 3, so now I am going to locate the position 212 by counting the base pairs of exon. So these are exons. So exon number 1 base pairs, that are 90 plus exon number 2 base pairs, plus exon number 3 base pairs. And this is my single base mutation, which is exactly present at position number 212. Now I will design primers for the detection of this single base mutation by designing primer for this point. So I'm going to use Primer Blast software to design primers. So this is Primer Blast software. In this window, you will put the accession number of your gene for which you are designing primers. You can also put the sequence of your gene in this window. So as this is the sequence of my gene, so I will select the whole sequence and then copy this sequence and paste this sequence in the window. So you can use both accession number and the sequence in this window. So I am putting the accession number of my gene. So leave this section. So you can also upload that sequence. Leave this section. So here you will put the forward primer sequence that you have selected as your forward primer sequence, and in this window you will put the sequence of your reverse primer that has selected as reverse primer sequence. So in ARM-PCR first run you will use forward outer plus reverse outer primer. So first of all I will design the forward outer plus reverse outer primer. So as in the first reaction we will use the forward outer and reverse outer primer. So we need to design forward outer and reverse outer primer. So how to design forward outer and reverse outer primer? So here I will put the sequence of reverse outer primer. So now I will show you how to design the forward outer and reverse outer primers. The outer primer should always select it from the ends of the exons. So I will select from here the sequence of forward outer primer, and the size of the primer should be between 20 to 25 or 22 to 25, in the range of 22 to 25. So no, so I have selected the sequence of 24 base pair as my forward outer primer. So I will copy this sequence and paste this sequence in the forward primer window. So now I am going to design reverse outer primer. So the reverse outer primer should always start from the right end of the exon. So the size of reverse outer primer is also should be in the range of 22 to 25. So I have selected 24 base pair sequence of reverse primer. But the reverse primer should not directly paste into the primer blast window, but first of all you should convert it into complementary sequence with the help of reverse complement software. So take the sequence, copy it and paste it in the reverse complement software window. So I will take the selected sequence and paste it in the reverse complement. Click the reverse complement it will give you the complementary sequence of your selected sequence. Now copy this sequence and paste this sequence in the reverse primer window. So just leave the rest of all and click the show result in a new window and click get primers. So get primers, show results in a new window. Wait for the software to give you the results. So the software has given the details of your primers. These are the length and size of your primers, and this is the location of your primers in the gene, and this is the melting temperature of the primers. So now I need to calculate the average melting temperature of both primers on which they will anneal to the template DNA. So I will calculate the average temperature by adding melting temperature of both primers and dividing it by 2. So 69 plus 65 which is equal to 134, dividing by 2 equal to 67. But this temperature is more than the suitable temperature, but we need to have the melting temperature of primers within range of 50 to 60 degree. So I will decrease the size of my primers by decreasing the number of base pairs. So this is my forward outer primer, and I will take 21 base pairs instead of 24 base pair sequence. Copy that sequence and paste it in the forward primer window. I will also reduce the size of reverse primer, and I will take 21 base pair reverse primer. Copy the sequence and will paste the sequence in reverse complement software. To get complementary sequence of this sequence. Click reverse complement. After getting the complementary sequence, I will copy the sequence and paste the sequence in reverse primer window. And then get primers. Now again the software has given me the details of my primers, and again I will calculate the melting temperature of both primers by calculating the average temperature. (63 plus 61 equal to 124) and dividing by 2, which is equal to 62. Now this is a suitable temperature for the primers, and primers can easily anneal to the template DNA because there can be difference of 2 to 5 degree within calculating value of melting temperature and the actual experimental melting temperature. So now I have designed my forward outer primer. This is my forward outer primer, and this is my reverse outer primer, and both of these primers has suitable melting temperature within the range of 50 to 60 degree, and they can easily work on 50. Now how to design the internal primers. Now we will make a primer containing base which will be complementary to the mutated base. And the complementary base which is complementary to the mutated base can be present in either forward internal primer or in reverse internal primer. I am adding the mutated base complementary base in my reverse inner primer. So I will design the reverse internal primer containing a base which will be complementary to the mutated base. So the inner primer should always design So the internal primers are always designed from the side of mutated base. So this is my forward primer from the left side of mutated base. So as the first reaction we will use forward outer and reverse outer in the PCR. So I have already designed my forward outer and reverse outer primers. So in the second reaction I will need forward inner and reverse outer primer. So in the reverse primer window I will paste the already designed reverse outer primer, and for forward inner primer I will design it. So these are details of my forward inner primer and reverse outer primer, and again I will calculate the average melting temperature of both primers. 60 plus 61, which is equal to 121, dividing by 2 equal to 60.5, and this is a suitable temperature within the range of 50 to 60 degree. So my second reaction primers have average melting temperature 60.5 degree. So for the third reaction I will paste the forward outer primer that has already designed, and now I will design reverse inner primer. So I will paste the forward outer primer, and in the reverse primer window I will design reverse inner primer. So I will select the sequence from the right side of mutation site, So I am selecting the reverse inner primer of 20 base pairs because I am going to incorporate one base pair which will be complementary to the mutated base. So I will add this sequence in reverse complement software, reverse complement, and after getting the complementary sequence I will copy the sequence and paste in the reverse primer window. Get primers. So now I will calculate the average temperature of my reverse inner primer and forward outer primer. +63 plus 55, which is equal to 118, dividing by 2 equal to 59. So this is a suitable temperature within the range of 50 to 60 degree, and these primers can easily anneal to the template DNA and give us product. So now I have designed my all 4 primers. This is my forward primer of 21 base pairs, and this primer consists of normal or wild nucleotides, wild type nucleotides, and this is my reverse inner primer in which I am going to incorporate a base which will be complementary to the mutated base. In order to make reverse inner primer, the complementary base to the mutated base. So we will add complementary base. As in case of HAMP gene mutation, the wild type guanine has converted into adenine, and the complementary of adenine is thymine. So I will add thymine in my reverse inner primer, and that thymine will make bond with a mutate. My 4 primers, and these are my 3 reactions. Thank you for watching, guys.